Question: why do some Australians become climate advocates while others remain skeptical, even when exposed to the same information? Understanding the dynamics of belief systems can help us answer that. I'm Kavisha, and today I'll be taking you on a journey to discover how belief systems came to be and how we see it in action in every aspect of our life. So, of all topics, why climate change? To set the stage, a Lowy Institute poll found nearly 2 out of 3 adults believe climate change is the most serious threat to Australia's national interests, and this is an 18-point increase in 5 years. Australia has a big stake in these issues. It's one of the world's top greenhouse gas emitters on a per capita basis and is in the top 20 for total pollution, with a footprint greater than Britain or France. It's already experiencing the effects of climate change, including increased heat waves and mass coral bleaching on the Great Barrier Reef, and is the global leader in mammal extinction. Not to mention the recent algal bloom we experienced in South Australia. So, for those of you who don't know, the 2019 Australian federal election was dubbed the climate election, where the opposition campaigned on a relatively ambitious climate action, but the government was returned on a status quo policy. It highlights how big of an issue it is to pay out on a national scale and even have a whole election named after it. Climate change, surprisingly, is a divisive issue among the Australian public, and there is substantial disagreement over its causes, severity, and policy responses. There is a strong age cohort divide, with younger people holding stronger pro climate attitudes than older ones, and the same can be said for urban and non urban populations as well. So, the main tool to address this divide in opinions are belief systems. A belief system is, well, a system. It may be possible to have a single propositional belief about one thing, but generally speaking, they tend to hang together in a scheme. So we have a conceptual scheme which functions for the individual in an interesting way. So if I hold certain preconceived beliefs about a certain topic, chances are it will influence how I see other things as well. Before we dive into the theory and maths, we need to have a clear idea of what a belief system is. Imagine having a bubble around the individual, and the bubble consists of lenses which color and distort and shape what's outside the bubble. So, if you're inside a belief system or if you've adopted a belief system, it makes you see things systematically in terms of that system. Coming back to our debate on climate change, a study done at Monash University found that Australians fell into 6 groups in terms of climate beliefs. They found that people could be placed on a spectrum with regard to their views on climate beliefs. At one end would be the alarmed group, which are highly concerned people who are convinced of the science and are already taking action to mitigate the effects. On the other end were the non believers who were strongly skeptical of the genuineness of climate change and went so far as to believe it to be a hoax. But however, the 64% of people in the middle belong to the following categories: concerned, cautious, disengaged, and doubtful. These groups had varied belief, awareness, and willingness to engage. I've dubbed them as the pliable group since they appear more open to change their minds. So, to the math behind our modeling. So, how exactly do we apply these belief system dynamics to a climate change example? That's where the math comes in. Don't let the math scare you just yet. We'll get to the important bits shortly. But formally, to set some precedent, we consider a population of more than 2 individuals concurrently discussing their opinions on more than one topics. So each yellow circle you see is a single agent or person in our belief system, and the black dots inside represent the logical interdependencies between each topic for that individual. So when they interact with each other, these beliefs will change. In this slide, we're diving into the data set description, particularly focusing on the 6 Australia segmentation that we talked about earlier. This model is inspired by a similar study conducted in the US, known as Global Warming's 6 Americas, which has helped classify Americans based on their beliefs and attitudes towards climate change. So the original Six Americas model had a 36 question screener, but for efficiency, it was later condensed into just 4 questions. And this method had a true positive accuracy rating of 70% to 87%. So today we're diving into the profiles that ranged from alarmed, who were the most worried about climate change, to the dismissive, who outright rejected it. In between, we have the concerned, cautious, disengaged, and doubtful. Interestingly, when compared to studies from 2011 and 2016, we observed an increase in the alarmed group and a decrease in the disengaged. So this shift highlights a growing awareness and concern about climate change in Australia. To simulate this in our deGROOT model, we employed specific data manipulation techniques to set the initial distribution in our matrices. So this will help us accurately reflect the starting attitudes and beliefs within the population. Moving forward, we'll explore the survey topics that help categorize these personas and discuss where each lies on the spectrum of concern and belief. So the Six America Short Survey questions are as follows. Topic 1, how important is the issue of global warming to you personally? Topic 2, how worried are you about global warming? Topic 3, how much do you think global warming will harm you personally? And topic 4, how much do you think global warming will harm future generations of people? We have renamed them as important, worry, personal, and future for for ease of reference in our future simulations. Now that we have defined the 6 personas and the 4 topics of discussion, we use some data manipulation on the survey outcomes to see what the most common response was for each topic by each persona. I'll give you an example on how to read the graphic here. So for instance, topic 1, which is how important climate change is to each participant. The dismissive people said it wasn't important at all, the doubtful people said it was not too important, and so on. So we've done a similar visualization for the 4 different topics. I'll let you just have a quick look here for a few seconds. Now we'll move on to topics 3 and 4, and the way to read the graphics is the same. So from this slide onwards, we move on to some real simulations of the data. The main takeaway here is how each persona is represented in terms of their proportion in the population, which corresponds to the survey data that we collected. So the concerned group makes up 28% of our sample, showing a significant portion, followed closely by the alarmed at 25%, cautious at 23%, and then we have doubtful at 14%, dismissive at 17%, and lastly, the disengaged group at 3% of the population. First, we define each individual's opinion on the M topics, starting at time t equals 0. So we have used the Likert scale values mentioned before to infer the initial values for x0. Here, like +1 indicates strong agreement with the topic, and -1 will be strong disagreement, with 0 being neutral. So if you look at X10, which is the alarmed group, and their initial starting opinions on the topic 1, which is how important they thought climate change was, you can see they have values across topics, values of 1 across topics 1, 2, and 4, which means they had a very strong response. So they agreed that climate change was really important. Secondly, they were worried about climate change. And lastly, they thought climate change would really have adverse effects on the future generations. But for topic 3, which was their perception of how influential climate change would be on themselves, they said it was slightly less around, still positive, but not too extreme. So now we move on to the C matrix. The C matrix encodes how a person's own beliefs on different issues constrain each other. This means how much belief in topic 1 affects beliefs in topic 2. Specifically, the C matrix encodes how strongly beliefs on different issues are dependent or independent. So the responses on the Likert scale were also used to construct the persona opinion vectors for the four topics of discussion. For instance, if someone is very worried and thinks climate change is important, there is positive coupling. If there is low worry but high importance, the link is weaker. If they are disengaged, there is zero coupling, and if dismissive, there is near zero or even negative reinforcement between topics. We had constructed six different C matrices for each persona, which introduce heterogeneity into the C matrix or the logic matrices of each persona. Finally, the W matrix indicates the interpersonal influence or the degree to which one agent listens to or is influenced by another. We used a Watts-Stragatz network for generating W matrix, and this is suitable because it's useful for generating small world networks that have high clustering, which is similar to social networks where friends are likely to know and talk to each other. So now we look at some actual results from our simulations. We ran a loop where we combined the initial beliefs x0, and then we made that matrix interact with the C and the W. And then we mapped how each agent updated their beliefs across time steps from 0 to 100. So if we can see on the left side graph that all of the agents' opinions converge to 0, which is neutral across all topics over 100 time steps. And we have a clear visualization on the right where we mapped the average opinion for each persona for each topic. And we can see that though there is initial diversity at t equals 0, that agents move quickly towards a common region. So this suggests strong social influence and connectivity that we introduced from our W. Induce a change in the former results. First, we could induce stubbornness of agents, or secondly, we could introduce a lower triangular or block triangular matrix in C, which is the cross-topic correlation matrix. So the first method we tried is to introduce a stubbornness parameter di, which is how attached each agents are to their initial beliefs. So here we move from pure degree to a Friedkin-Johnson model with stubbornness. So here the set di, if it's equal to 1, it will be the fully influenced O model, and if di equals 0, that will be fully stubborn, meaning the agents would never change. And x0 is the initial beliefs anchor. With the introduction of the stubbornness parameter, we can see that the agents now don't converge to a single value, but rather they adjust slightly at the start and then flatten out at different levels. We can see that each agent settles at a personal equilibrium where their final opinion is a balance between social influence and their own initial beliefs. If you look at the topic level averages on the right-hand side graph, you can see bands forming in the topic level averages for worry and future, which represent groups with similar stubbornness and initial opinions. So, what are we going to do next in our analysis? I think first we would like to revisit the construction of the C matrices. This is essential because we would like to identify maybe lower triangular or block triangular interdependencies between topics. And this might really enhance the understanding of the relationships between in the data. And secondly, imagine if the initial distributions of x0 and the stubbornness parameters were sampled from a beta distribution rather than being hard-coded like it is right now. This shift could introduce variability that might significantly affect the model's outcome. I think it's important to consider how this stochastic approach could reflect a most realistic scenario where beliefs and stubbornness aren't fixed but may vary. Moreover, I would like to think more about the future dynamics of our population. So, based on the current trends, how would changes in the population proportion of each persona impact our model in 5, 10, or even 15 years? I think this forward-thinking approach will allow us to anticipate shifts in the population and adapt relevant policies or strategies to accurately depict those changes in population. And this brings me to the end of my presentation. Thank you.